Hi, welcome to College Algebra, Lesson 6.1 and 6.2. So yes, this is a full-length lecture, just like we were in class, 75 minutes long, and we will be covering section 6.1 and 6.2, which will keep us on track for finishing chapter 6 on time for exam 4. So welcome to class. Today we're going to be going over exponential functions. An exponential function is any real number where A is any real number and B is any positive, that's important to remember, positive real number that's not equal to 1. Then we have the function f of x is equal to a times b to the x. And this is called an exponential function in base b. So this is base b. Before we get too involved with the exponential function, I do want to take a moment to review some of our basic properties of exponents. First off, remember that when we have the same base, base b raised to the x power, base b raised to the y power, that is equal to base b, the same base, with our exponents added together. So what that means is if I have 2 raised to the third power multiplied by 2 raised to the sixth power, that is equal to the 2, that's our base, raised to the 3 plus 6, which equals 2 to the 9th power. And let's look at that a little bit more in depth. If I have 2 to the third power, that's 2 times 2 times 2, correct? And then 2 to the 6th is 2 times 2 times 2 times 2 times 2 times 2. So that's 1, 2, 3, 4, 5, and 6. So now I have 2 cubed multiplied by 2 to the 6th. And how many 2's do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's how we get 2 to the 9th. Our next one right here is, you see that we have b to the x divided by b to the y. Well, that's going to be b to the x minus y. That's the way it works if x is the larger number. So if I have 2 raised to the 7th divided by 2 raised to the 3rd, that is equal to 2 to the 7 minus 3, which is 2 to the 4th. Now let's look at that expanded out. So if I have 2 to the 7th, that's 1, 2, 3, 4, 5, 6, 7 2's. 1, 2, 3, 4, 5, 6, 7. Gotta double check my work. Divided by 2 cubed, which is 1, 2, 3. Everybody agree? Okay. Now I can factor out. That can go, and that can go. So what do I have left? I have 1, 2, 3, 4 2's left, which is 2 to the 4th. Guess what? That's the same thing right there, isn't it? Alrighty. So moving on. Property number 3. You see here that it says if I have b to the x raised to the y power, that's b to the xy. So that means if I have 2 cubed raised to the 5th, that's the same thing as 2 to the 3 times 5, which equals 2 to the 15th. I'm not going to take time to show this, but there's the property identified. Now, number 4. Notice that number 4, we have different bases. We have ab raised to the x. So this is going to be equal to a raised to the x, b raised to the x. Okay? So if I have x, y, both raised to the 10th, that is equal to x to the 10th and y to the 10th. Number 5. If I have a, b, again, different bases, raised to the 10th power, this is the same thing as a to the x divided by b to the x. Same principle as what we did over here. Number 6. The nth root of a is equal to a raised to the 1 over n. And most people remember that if I have the square root of a, that's equal to a to the 1/2. So since you most likely have this pretty well memorized, if you're dealing with different numbers, let's say a 3 and a 4, make sure that if you can't remember, which is the denominator, which is the numerator, go back to what you know. You know that the square root of a is equal to a to the 1/2, which would be 1. So your 1 would go right here. So just use that as a map to help you undo whatever needs to be changed from this position into this position. Number 7, b to the negative x. Whenever you see a negative exponent, that tells you that it is not happy where it is located. Let's change that to green so you can see a little bit better. So when you have a negative exponent, it says I'm not happy where I'm at. I want to move, okay? So right now it's in a numerator. So it says I want to move to the denominator. If you move me to the denominator, I'm going to have a positive attitude with a positive sign. You see I went from a negative to a positive. If it was in the denominator and it had a negative sign, all you have to do is move it to the numerator, and now it has a happy attitude on life, and we have a positive sign. Okay. Number 8, anything, I don't care what it is, raised to the 0 power, whether it's 1 million or negative 1 million. If it's raised to the 0 power, it is equal to 1. It doesn't matter how big or how small the number is. Anything raised to the 0 power is always equal to 1. We have a very common exponential function called e to the x, and it models very many real-world situations, so many that we came up with a special notation for it, okay? And e to the first is equal to 2.72. I want you to please get out your calculator. I'm going to get out mine. Now this one here is not one that you can use because this is a graphing calculator, and at UWF in college algebra you are not allowed to use a graphing calculator. But I don't have any other calculator on my computer that I can show you, so this is the one I'm going to be using. So what I want you to do is I want you to get out pause the video, go find your calculator. Seriously, pause the video, go find your calculator right now. And when you have it back, then just when you've got your calculator, just push play so that you're ready to go again. And look at your calculator for the exponential function. On mine, it is right here. It's in blue right here. So I'm going to have to hit second and then this button here to get my e to come up. And then I'm going to put in a 1 and I'm going to hit enter. And you can see that equals 2.71828 blah blah blah. Okay, I need you to find on your calculator how you can do this, because you're going to need to have the skill for the exam. Okay, you have to have the skill for the exam, knowing how to use the exponential function on your calculator. If your calculator doesn't have e to the x and doesn't have the natural log or the logarithmic functions, you need a different calculator. The TI-X30A will do everything, and it's under $10 at Walmart. So anyway, so grab your calculators, make sure that you can get this number out of your calculator by putting in a 1 for your x. Now let's come down here and we are going to simplify these expressions right here. Okay, so we're going to start here with exercise 1. Notice that all of this is within the parentheses and all raised to the cube power. So that means this is going to actually be 4 raised to the 3rd power, because 4 right here is raised to the 1st power. And so 1 times 3 is simply 3. So it's 4 to the 3rd power. And then x squared, the 2 times 3, is going to be x to the 6th. Now I have y to the 6th. 6 times 3 is 18. So it's y to the 18. And then we have z cubed raised to the 3rd power. So that's 3 times 3, which is 9. And so what we were doing is we were applying actually number 3 right here. Number 3 is the one we were applying. Now we're not quite done. I need to take this right here and change it into a 64, because 4 times 4 is 16. 16 times 4 is 64. So my final answer is going to be 64, x to the 6th, y to the 18, z to the 9. And that is my answer. Okay, let's look at problem B. So problem B, when we look at it, notice that right here I have an x here and I have an x here. So I really want to combine those two in the very first operation. And I also want to reduce my 2 and my 8, because 2 will go into 2 1 time, 2 will go into 8 4 times. So I actually end up with 1/4 right here. And then x cubed and x to the 6th, we're going to be adding those exponents, so that becomes x to the 9th. And then I have y to the 7th, z to the 10th. In my denominator, x to the 5th, y cubed, and then z to the 6th. Now, x to the 9th, x to the 5th. 9 is greater than 5, so the 5 is going to come up. 9 minus 5 is 4, so it's x to the 4th. My y to the 7th, y to the 3rd. 7 is greater than 3, so the 3 is going to come up. 7 minus 3 is 4, so it's going to be y to the 4th. Z to the 10th, z to the 6th. 10 minus 6 is 4, so I end up with z to the 4th. So this is actually going to be rewritten as this, and this is more proper of a form here. And right here is our final answer. Okay, what I want you to do is I want you to pause your video right now, and I want you to solve number C, okay? And then when you're done, push play to see if you got the right answer. I'll see you back in just a moment. Welcome back. How did you do? Here's our final answer. Our final answer is 27 times x cubed divided by 125 times y to the 15th. I hope that you got it right. If you did, send me the code word apples via texting or email, or if you're listening to this for another class, send your professor the code word apples via email. And if you got it wrong, I'm thankful you tried. I'd like the code word pear, P-E-A-R, sent to me or to your professor so that they know that you tried it and you may have made a mistake. So let's go over how we did this. First, it's going to be 3 to the 3rd power. We got to bring this third in to each term within the parentheses. So it's going to be 3 to the 3rd, which is what I have here, x to the 4th times 3, so it becomes x to the 12th, y to the 10th times 3 becomes y to the 30th, 5 to the 3rd, x to the 3rd raised to the 3rd becomes x to the 9th, y to the 15th raised to the 3rd becomes y to the 45th. Now I'm going to reduce within. So my 3 cubed is 27. X to the 12th minus 9 is x to the 3rd. I have y to the 30th, but I have y to the 45 in the denominator. So that means that 30 is going to come down. And so it's y to the 15th, and my 5 cubed is 125. So again, send me the code word or your professor the code word 120, or how about apples if you got it right, and pears if you made a mistake and got it wrong. Let's move on to page number 2. Evaluating exponential functions. Sometimes you're going to need a calculator for this, sometimes you don't. Just depends on the actual values that were given. So this one here says evaluate f of 1 when f of x is equal to 3 to the negative 2x. So remember that when f of x is equal to 3 to the negative 2x, that negative says I'm not happy there and I want to be moved to the denominator. So to make that exponent positive where it's happy, we need to move that into the denominator. So this is really what the function is looking like that we're going to be evaluating. So this is going to be equal to 1 over 3 to the 2 times x, which is 1. So this is 1 divided by 3 squared. And well, 3 squared is simply 9. So here is our answer right there. So f of 1 is equal to 1/9. F of 0 is going to be equal to 1 divided by 3 raised to the 2nd times 0, which is equal to 1 divided by 3 to the 0, which is 1 divided by 1, which is just 1. Oh, my computer's getting hot. So there we go. So that is our final answer right there. Coming on up to example number 3. Example 3 says evaluate f of x when x equals x squared plus, or e to the x squared plus x when x is equal to 2. So we're just going to plug in wherever there's an x here, we're going to put in the number 2. So it's e to the 2 raised to the 2 plus 2. This x, or this 2 right here, and this 2 right here is actually because x is equal to 2. So this is equal to e. 2 squared is 4 plus 2 equals e to the 6th. So I told you to grab your calculator, so grab out your calculator and let's punch in e to the 6th. So for my calculator, it's going to look like this. I'm going to hit this, and then I'm going to hit this. I'm going to put a 6 right here. I'm going to hit enter. And I'm going to get 403.4. If I rounded just 2 decimal places, 43. So that's what I want you to look for. Grab your calculator, make sure you can do this. And this should equal 403.43. And that is going to be your answer right there. Okay? Please make sure you check this on your own calculator. Next, I want to go ahead and evaluate it when x equals -1. So this is going to be equal to e to the -1 squared plus -1. So this is equal to e. -1 squared is just 1, and this is going to become -1. So this is e to the 0. Anything to the 0 power is just 1. So my final answer right here is just the number 1. Okay, we're going to talk about growth and decay exponential functions. So some of our definitions concerning exponential functions with growth and decay. For the initial amount, why not? Now, it says why not has to be greater than 0. Well, obviously it has to be greater than 0 because this is the initial amount of whatever it is that we might be investing, or the problem that we're looking at, whether we have money that we're investing. Okay, we can't invest nothing, and we can't invest a negative number. And if we're looking at the kill ratio of bacteria, if we don't have any bacteria to begin with, we can't kill it, right? So we can't have a decay. So obviously y naught has to be greater than 0. And the equation is y is equal to y naught, the initial amount that we have, times e to the kt. And if k is greater than 0, this k right here is greater than 0, we have an increasing function. If this k right here is less than 0, we have a decreasing function. So we come down to number 4, and it says for each function, identify y naught and k, and then determine if they are growth functions or decay functions. So looking at our A here, the very first thing I want you to identify is what is y naught. Y naught is the numerical value in front of the e. So in this case, y naught is equal to 10. The next thing I want you to identify is k. K is equal to the number in front of t. So this is negative 0.9. Notice that k is less than, right here, it's less than 0. So therefore we have a decreasing function, which is a, therefore, decay. Okay? Now, let's look at problem B. So problem B, it says identify y naught. Remember, y naught is simply the numeric value in front of the e. So that's equal to 7. Next, we want to identify k. K is the numeric value in front of t. So that is 1.5. 1.5 is greater than 1, therefore I have an increasing function. If I have an increasing function, I have a growth. That easy, okay? So identify your y naught, identify your k. If your k is negative, it's a decreasing decline. If it's positive, then we have an increasing growth. Now we're going to be learning how to write equations of exponential functions when we are given 2 points. Very much like we did when we had quadratic equations, and we were given 2 points, maybe a vertex and one other point on the graph, and we had to write an equation that represented that quadratic function. We're going to do the exact same thing, but this is with exponential. If you follow my steps every single time, you will get the right answer. It may not make a lot of logical sense, but I promise you it works, okay? So here we go. So it says given 2 points on the graph, we can find the equation of the exponential function. It says find the exponential function f of x equals a b to the x, whose graph goes through the points 0, 2, and 2, 18. So step one. So step one is we are going to solve for a. So solve for a, okay? And I'm going to choose a point to start with. I'm going to choose the point 0, 2. It was the first one. It doesn't matter. You're going to get the same answer no matter what. Okay, so I'm going to choose the point 0, 2 to start with. Remember that f of x is just another way of writing the letter or the coordinate y, okay, in a coordinate system. So that means that this right here is an x and this right here is a y, also known as f of x. So if I have f of x is equal to abx, and I said the first thing I'm going to do is solve for x using these points, I'm going to take this value x and I'm going to plug it in there. I'm going to take this value y and I'm going to plug it in for f of x. So I have 2 is equal to a b to the x, which is 0. Remember, I'm solving for a. So let's just rewrite this mathematically. This is equal to 2 is equal to a b to the 0 is just 1, which is a. Therefore, the 3 dots here means therefore a is equal to 2. Alrighty? Part 2. Now we're going to solve for b. So solve for b. And when we solve for b, we're going to use this other point right over here and the fact that we know what a is equal to. Remember, this is my x, this is my y, okay? And y is equal to f of x, okay? So I have f of x is equal to a b to the x. My f of x is equal to y, which is 18. It equals a, which is 2, times b to the x. My x is also 2 from right here, okay? Remember, I'm solving for b. So in order to solve for b, I'm going to take and divide both sides through by 2. And that's going to disappear. And I'm going to get 9 is equal to b squared. I'm going to take the square root of both sides. And I'm going to get, therefore, b is equal to plus or minus 3. But remember, it can't really equal positive or negative 3 because we said at the very beginning that b must always be positive. Therefore, b equals 3 only. Okay? So that's very important. It cannot equal negative 3. So now we're going to go back and we're going to put this all together into our final answer. So our final answer is we have f of x is equal to a, which is 2, times b, which is 3, raised to the x. And that is our final answer for problem 5. Okay? Step 1, solve for a, which went right here. Step 2, solve for b, which went right there. And then really step 3 is put it all together. Okay? Let's do another one right here. Number 6, we're going to do the exact same thing, same order. Step 1, solve for a. Remember, we have f of x is equal to abx. I'm going to use point, let's use the first one here, 2, 6. Okay? So this is my x, this is my y. So I have 6 is equal to ab squared. I'm solving for a. I'm going to divide both sides through by b squared. And I'm going to get therefore, because that's going to go away, a is equal to 6 divided by b squared. Now I didn't solve for a number, but I did solve for what a is, and it's written in terms of what b is. So step 2, solve for b. We're going to use this point over here. So I have f of x is equal to abx. And I know that my point that I'm going to use is 5 and 48. Now, that means, here's my y. 48 is going to equal, what is a? A is 6 divided by b squared times b to the x, which is 5. Okay, so this is going to be equal to 6b to the 5th divided by b squared. But we can simplify this because we have the same base, b to the 5th, b squared. 5 is greater than 2, so we're going to be bringing the b up. So this is equal to 6b cubed. So now I have 48 is equal to 6b cubed. I'm going to divide both sides through by 6 because my objective is to solve for b. So when I divide both sides through by 6, that goes away. And I get, therefore, b cubed is equal to 8. Now I'm going to take the cubed root of both sides. So if I take the cubed root of both sides, the cubed root of b is b. The cubed root of b cubed, rather, is b. And the cubed root of 8 is 2. So now I know what b is equal to. B is equal to 2. Coming back over here, though, let's look at a. A was solved actually in terms of b. So a is equal to 6 over b squared. Well, let's substitute in what b squared equals. So this is going to be equal to 6 over, b is 2, so it's 2 squared, which is 6 over 4, which equals 3/2. So a is equal to 3/2 right here. So that is what a actually equals. So now we need to put it all together for our last part. And I can say that f of x is equal to a, 3/2, times b, 2 to the x. Okay, the exact same form as what I've put over here. And then let's make sure we circle our final answer right here. Now, I have another problem down here, exercise 7. Back this up if you need to, okay? Back it up if you have some questions. And, oh, also, I wanted to mention that sometimes in web work, I don't know if this has been changed or not, but sometimes in web work, the A is the B and the B is the A. So they have you enter what we define and how we do it in class as A's and B's. Web work can be backwards. So pay attention to that when you put it in. If it doesn't like your A's and B's, you have to look at the format and decide how to input the information properly. So here's number 7. I want you to take and try number 7 on your own. It's right here are your points, okay? Pause the video, solve it on your own, and see if you get the right answer. I'll see you back in just a moment. Welcome back. So here's the correct final answer for number 7. This was a very tough one. If you got this correct, send me the code word or your instructor the code word green, whether it's texting or email, however you normally communicate with your instructor. Send the code word green if you got it right. If you made a mistake, even if it was a slight mistake, go ahead and send us the code word blue. That lets us know that you tried it and that you just made a minor mistake. If you did not make a mistake, I'm going to have you skip forward past this. We have to do 6.2 in today's lesson also, but you can skip the explanation of this particular problem. We're going to have step 1, and that is solve for a. I'm going to say f of x is equal to ab to the x. I'm going to use my point. I'm going to use the first one here, which is 1 and 1/5. Okay? Now to solve for a, I'm going to let 1/5 be my y right there. So I'm going to have 1/5 is equal to ab to the x, which is just 1. Now remember, I'm solving for a. So this is just b, so I'm going to divide both sides through by b. Now, remember, this right here is a fraction divided by a whole number. So I could rewrite it as 1/5 divided by b divided by 1, because a whole number is just divided by 1. That makes it a fraction divided by a fraction. So I have 1/5 multiplied by the reciprocal here of b divided by 1, which is 1 over b. So this is 1 times 1 is 1. 5 times b is 5b. So right here, that factors out to nothing. And I end up with, therefore, a is equal to 1 over 5b. Now, part 2, solve for b. Now, we're going to have the same format. It's f of x is equal to ab to the x. I'm going to use my second point right here. So I'm going to use point 3, 1 over 125. So I have 1 over 125 is equal to a. What was a? A is 1 over 5b multiplied by b to x, which is 3. Now, over here, I can say that this is the same thing. 1 times b cubed is just b cubed, correct? And then over 5b. Well, now I can simplify right here because this is b to the first. So 3 minus 1 is 2. So this becomes b squared over 5. So what I have here is I have 1 over 125 is equal to b squared over 5. I'm solving for b. So that means I'm going to multiply both sides through by 5, because what I do to one side, I must do to the other, and that cancels those 5s out. And 5 will go into 5 once. 5 will go into 125 25 times. So I end up with 1 over 25 is equal to b squared. Now I have to solve for b, which means I'm going to take the square root of both sides. So when I take the square root of b squared, I get just b. And then the square root of 1 is just 1, and the square root of 25 is just 5. And remember, it's going to be positive because b must always be positive. Now, notice that right here, I solved a again in terms of b. So I'm going to need to substitute my value for b into a to find out for the actual numeric value that a is equal to. So since a is equal to 1 over 5 times b, and b is 1/5, this is 1 divided by, well, that's going to just equal 1. So 1, because 5 will cross right out. Okay? So therefore, a is equal to 1. Well, if a equals 1 and b equals 1/5, that means f of x, which equals a, 1, so I don't even need to write that down, times b, 1/5 to the x. And that is our final answer. I hope you figured out where you may have made your mistake and in that particular problem. And if not, feel free to contact me or your UWF professor so that we can help you understand this important concept, because I can assure you that you will see that particular concept on the next exam. So there's a funny for just a moment. We're into 6.2 and we're doing fine on time, so we will finish this probably even with time to spare. This is a very important concept. We are talking about the exponential functions and how to graph the exponential functions. Remember how you had to memorize the parent shape of the parabola and of the cubic and of the square root, the cubic root, the absolute value function, all the different functions you had to take and actually memorize. This is another one that you're going to have to memorize. We're going to be talking about the parent function, the parent shape, and some and how to recognize the exponential function and then doing transformations on them. So we have some distinct characteristics of the graph of the parent function of exponential. The first thing I want you to notice is that the exponential is in the form of b to the x, and b has to be greater than 0, it has to be positive, and it cannot equal 1. So the exponential function is a one-to-one function, which means it has an inverse that is also a function. The horizontal asymptote is the x-axis right here. Okay, so that is your horizontal asymptote. We get infinitely close to the x-axis. Visually, you won't be able to see that you're not touching it, but the reality is you never actually touch or cross the x-axis, or the horizontal asymptote in this case. The domain for the exponential function is all real numbers, negative infinity to positive infinity. The range is all positive real numbers, which is 0 to positive infinity. There is not an x-intercept. You'll notice on the graph here, there is no place that we cross over to the x-axis. We get infinitely close. Your eye cannot tell the difference, but you actually never cross it. The y-intercept is your one known point that we use to reference, and that is the point 0, 1. Now, you see right here I have two different pictures. The difference is we have one that's increasing, and that is based on the value of b. We've already talked about b. And if b is greater than 1, we have an increasing function. And increasing means as you read from left to right, you increase. You climb the mountain. Then we have, if b is less than 1, we have a decreasing function. So as you read from left to right, you slide down the slide. Okay? Now, it's important to remember that b is less than 1, but it can't be negative. So you're looking for a fraction between 0 and 1. And so when b is a fraction between 0 and 1, you will indeed have a decreasing function. Here's how we look at the transformations. Great rules. Okay, I'm going to give you the practical side of it. So going over the rules, so first, for any constant c and d, the function when we have c plus x or plus d, these are the shifts on the parent function b of x. So d is your vertical shift, okay, in the same sign. So if it's a positive d, you go up. If it's a negative d, you go down. Our horizontal shift c is always opposite of what you see there, because x always lies to you. If it's a positive, you know that you move in the negative direction. If it is a negative, you know you move in the right direction. The y-intercept is just going to shift up and over according to the horizontal and vertical shifts. The horizontal asymptote shifts however many units are associated with our vertical shift, d up or down. Our range also is affected by our vertical shift, and then our domain is consistent and stays as all real numbers, negative infinity to positive infinity. So those are the rules. Let's look at what this means in application. So for each function, find the horizontal asymptote, the domain, the range, the y-intercept, then plot a few more points to graph the function. I'm probably not going to plot a few more points. I will on the first one, and that'll be it. Simply because when I grade your exams, What I'm interested in knowing is, do you have the general shape correct? Do you have it increasing or decreasing accordingly? Did you get the horizontal asymptote in the right position? And did you do the transformation on the y-intercept? Did you shift it to the right location? That is the one known point. And each of those is worth 2 points on my exams. And so that problem is normally worth 6 points. 2 for the asymptote, 2 for the known point, and then 2 for the general shape of the graph. So I'm not too worried about plotting other points. I just want you to do general sketching. So here we go. If I have f of x is equal to 4x, you're going to notice first off that, well, let's look at our b. Our b is equal to 4. 4 is greater than 1, therefore I have an increasing function. Okay, you're going to notice there's no horizontal shift and there's no vertical shift. There's nothing else over here at all. Okay, so that tells me that my function, the y-intercept, is still the point 0, 1. So that's the y-intercept. The range is still going to be all positive real numbers, which is 0 to positive infinity. So my domain is all real numbers. And then my horizontal asymptote, there's no shift. So my horizontal asymptote, which is denoted by HA, is still y equals 0. So to plot this, we said it's an increasing function, which means I'm going to climb the mountain. So it's going to look something like this. If I put in a number 1 for right there, I would find actually that the next point is 1 right here. So I probably should go ahead and do that and get that quite right. So 0, 1, if I let x equal 1, my y would then equal 4, so 1, 4, and you can see that it climbs very quickly. That's why it's called an exponential function. And our asymptote is right here, right there. Okay, so we have done everything that it's asked us to do. Let's go on to the next problem. This next problem is a little trickier. If you notice that I have f of x is equal to 2 to the negative x. Well, I need this exponent right there to be positive. In order to make that positive, that 2 needs to move to the denominator. So that means this is 1 over 2 to the x. Now you can see that b is equal to 1/2. And because 1/2 is less than 1, we have, therefore, a decreasing function. Okay, so that's important. My b right here needs to be rewritten so that I have a positive exponent. Oh, that 2 should be an x. So let me correct that. That should be an x. Sorry about that. So it's 1/2 to the x. My x is now positive, so therefore I know that my b is 1/2. 1/2 is less than 1, therefore I have a decreasing function based on what we learned. I don't have a horizontal shift, I don't have a vertical shift, so that just simply means that we're doing the same thing as always. My y-intercept is still the point 0, 1. Right here, it's a decreasing function, so it's going to look like this. I'm going to slide down the mountain. But you got to remember that our horizontal asymptote is right there. Okay, so that's our horizontal asymptote is still y equals 0 because there's no horizontal shift, there's no vertical shift, there's nothing. Okay, so we're not doing anything except for plotting our basic exponential function. And then it asks for our domain. Our domain is going to stay the same, which is all real numbers. And then our range is going to be the same as always, which is 0 to infinity. And it can change. The range can change, okay? And it's about to change in about 2 more problems. For this problem here, I want you to pause the video and just see if you can solve this real quick. What I want you to plot is the y-intercept. I want you to shift it if it shifts. I want you to plot the asymptote, and I want you to take and get the shape. Okay, so pause the video. I'll see you back in just a second. Welcome back. So here's the correct picture right here of the graph. B is 8/5, which is 1 3/5, which is greater than 1. Therefore, we have an increasing function. We have no horizontal shift. We have no vertical shift. Therefore, our horizontal asymptote is still the x-axis. And our domain is all real numbers. Our range is all positive real numbers. And our graph then goes through the y-intercept. I didn't write that down. The y-intercept of 0, 1. And it's increasing. If you got this correct, why don't you send me the code word cold. And if you got it wrong, send me the code word hot. I know it's kind of contrary to what we would think, but let's go ahead and do that. And make sure, if you're listening to this lecture, whoever your college algebra instructor is, make sure you send them the appropriate code words: cold if you got it correct, and hot if you got it wrong. Here we go. Another one. Now this one changes things up a little bit. The last couple have been pretty consistent. However, this one here, we have a negative out front. So we're going to get to that in just a moment. So first thing I want you to do is identify B. B is equal to 3/4. 3/4 is less than 1. So therefore, we have a decreasing function. Okay? Now, there is no horizontal shift. There's nothing connected to this x to give me a horizontal shift. And there's nothing connected to the main function down here that gives me a vertical shift. So that means that my y-intercept is still the point 0, 1. So we're going to go ahead and plot that. And then it said decreasing. So I'm sliding down the slide. Okay? I don't cross the x-axis because it is an asymptote. Okay? So we'll draw on our asymptote. But there's one thing left that we have to contend with. Okay? And that's this negative right here. That negative takes this function right here and it flips it around the x-axis. So actually what happens is this point right here shifts to this point right there. We're flipping it over, and this whole thing flips over, so it ends up being drawn like this. So the pink function is actually our function that we were told to graph, which includes the negative right there. So we have negative 3/4 to the x. That is the function in pink. The green, okay, is this prior to the reflection about the x-axis. So the correct answer is the one in pink. That's our final answer. Looking at problem number 5. We finally have a shift on the vertical axis and the horizontal axis. So let's do number 1. What is our b equal to? Our b is equal to 3, which is greater than 1. Therefore, increasing. Okay? Next, we know that our y-intercept is right here. Let me go into Magic Ink real quick. We know that our normal y-intercept is right here. However, I have a shift down 3 units. So that's going to go 1, 2, 3 to here. And then I have a shift on my x, okay? Remember that when we have a shift on our x, if I have x plus 2 equals 0 and I solve for x, that's how I can easily see that x equals negative 2. And it's saying go in the direction, -2 units. So I'm going to start here, which is where my y-intercept is. I'm going to move it down 3 units because I have a -3 right here. So it's 1, 2, 3 right there. And now I move it over to the left 2 units. So 1, 2. So right here is where my new known point is. So it shifted from here all the way down here. 1, 2, 3, 1, 2. Okay, so that's how we got it there. Now, there's no reflection or anything else. It's an increasing function. So I know at this point it's going to increase from here, and it can't go anywhere below the line right below that value. My asymptote shifted down 3 units also right here. So my horizontal asymptote is y equals -3. So that is my horizontal asymptote. So always remember your vertical shift represents your horizontal asymptote. And our domain is all real numbers. And our range, now that shifted. With this vertical shift right here, our range rather shifted also. So it moved down to -3 to positive infinity. Okay, so our range also shifted. So that should be a -3 right there. And I think we've identified everything that we need to do. So we have our asymptote drawn, we have the general shape increasing, and we have our known point, 2 points each. Let's look at number 6. Number 6, the only challenging part really on this one is recognizing that you have the value e. Do you remember what e equals? Okay, e is equal to 2.7. So that way we know that our b, it equals e, which is approximately 2.7, which is greater than 1. Therefore, we have an increasing function. Okay, just straightforward. Look at your b, what's doing. So we know we have an increasing function. I don't have anything being reflective. I do have a shift on the horizontal and the vertical, but no reflection. So I have a vertical shift up. So vertical shift up 1 unit. That's that right there. And then x minus 2 becomes x, and a shift to the positive right. So I have a horizontal shift. It's -2, so it's going to be to the right 2 units because x always lies to you. That's why they're your x, okay? And so we have our y-intercept, which is our one known point. We're going to go up 1 unit and then right 2 units. So right there is our new known point, okay? So it shifted from here, up 1, over 2. We're an increasing function, so we know that our function looks like this. And we have our horizontal asymptote right there. Horizontal asymptote is y equals 1. It went up 1, okay? Our domain is all real numbers. And then our range also went up 1 to infinity. So it shifted up 1 with our horizontal asymptote. Our horizontal asymptote and our range are always directly correlated. Alrighty, our last 2 problems. So, starting with the equation, f of x is equal to 3 of x. That's going to be considered our parent function. Write the equation that results from shifting this function right 6 units, down 4 units, and then reflect it across the x-axis. So here we go. Just take it one step at a time. Don't panic. It's fine. Just one step at a time. So we write f of x is equal 3 to the x. That's what we're starting with. It says we're going to shift right 6 units. So if I'm shifting it right 6 units, remember x lies to you, so it's a -6. It says I'm going to shift the whole function down 4 units. So off the whole thing, I'm going to subtract 4. Okay? And then it says I'm going to reflect across the x-axis, which means I multiply the whole thing by a negative. So my final function is f of x is equal to negative 3 to the x minus 6, negative times a negative, plus 4. And that right there is our function. Now, our last one for the day, and then we're done. So we have f of x is equal to 1/2 to the x. This is write an equation that results from shifting it left 3 units. If I'm going left, that's in the negative direction. Remember, x lies to you, so that's going to be plus 3, okay? Up 5 units, that's positive 5. Oops. And then reflected about the y-axis. So all I have to do is stick a negative in front of that x, and it's reflected across the y-axis. Done. So this right here is our final answer. Okay? So I hope that this was a good video for you. I hope you enjoyed it. And this takes care of section 6.1 and 6.2. Take care, and I'll see you in Video Land soon for 6.3.